Weekly Contest 487, and here its first question. It is a question. So here it is given that we have to find. In this question, it is given that we have to count how many monobits are between 0 to n, and what is the monobit if in the if the integers binary representation has only one kind of bit, it is either 1 or it is either 0, then only it is a mono bit. So for 0, 1, 2, 3, 4, 5, we will see 0 has only representation as 0, so it is our monolithic bit. 1 has only represented as 1, so it is also our monolithic bit. But 2 has 1 0, its binary representation as binary representation, but so it is not our monolithic bit. And what about 3? 3 is also a monolithic bit because its binary representation is 1 1. Okay, so here, so we have to count each, and here is one crux that, see, 0 is counted because only 0 has 0 0, means represented as 0 as 1 bit. Okay, see, here is one crux that all 2 to the power n minus 1 will be included in our answer, else all the number will be not included, because 2 to the power n minus 1 is always represented as 1 1 1 1. Okay, and n minus 1 times, except of these numbers, except this, all the binary representation of all the numbers will include at least 1 0. Okay, at least 1 0 will be there, and only 2 to the power n minus 1 will have all the ones. So by this our answer becomes like, if n equals to 0, so if n is our 0, then our answer is 1. If n equals to 1 is there, so our answer is 2, because these two elements. If this, what this represent, that n is 2 to the power n minus 1, and if n plus 1 will become 2 to the power n, 2 to the power n minus 1. So what is this? So suppose this is 2 to the power n minus 1 and this is 2 to the power n. So what about n will be do? It will become 0. Okay, so whenever it is this answer, so our answer is log 2n plus 2. Okay, else our answer is log 2n plus 1. Simple. Now we will go to second question. So second question is also very simple. Today's LeetCode problems were very simple for first 3 questions. So the second question is like, this second question is like, we have to find the final element after subarray deletion. See, we are given a array, so Alice can delete any of the subarray, and Bob also can delete any of the subarray if the size permits. Okay, so in this question what we have to do, there we are given a array num. Okay, here we are given a array num. Num has some elements like this. Okay, so ls can remove any number of subarrays, means any amount of subarray. Similarly, Bob can also see, ls can remove any size of subarray. Okay, if the size permits, and similarly for Bob also can do any size, remove of any size of subarray. But Alex wants to maximize the last element and Bob wants to minimize. So I solved this question in only 1 minute. And how I solved? Just writing this code. If you will see first this code, then you will see why I am doing this. Maximum of 0 or last, means whatever the first element and last element's maximum will be there, it will be our answer. Why it is always true? because if suppose Li's remove these elements, then Bob what will do? Suppose these elements our max, this element is our maximum, this is our maximum for now. Then if Ls removes this element, Bob will definitely remove this element. So our last element will remain, because he doesn't want to maximize this now, he wants to minimize. And what if he will remove all the elements? Then also it will be remain for the Bob. Bob cannot remove this element. If Ls remove all the element, the Bob cannot remove this. So our answer will become either the maximum of first or last. Okay. This question is directly a linked list based question. So here we are given a rider is there, a driver is there, and a system is there. So what is there? If if void add rider is there, add rider will write a rider here with int I. Add driver will add a driver here. Suppose this is a linked list, this is also a linked list. Suppose add rider happens something. If the second first what we have to do, add rider, which is done. In English we can add simply the riders. First of all, this rider will be null, this driver will be also be null. So whenever it will give, we will write add the rider, we will add the driver by the linked list. If we want to match the driver, what we will do, we will match this first and just place the pointer to second for the rider and for similar for the driver, and remove this from the rider and driver. And if we want to cancel the rider, then what we will do, we will traverse this whole linked list and cancel delete this element from the linked list node. Okay, so here is the code. This is the struct of the linked list. First of all, then I have made a rider, then driver, then first of all the rider is null, driver is null. So here is the insert function for the rider and the driver. It is the insert function of the linked list. Okay, whenever we have to add driver, what we will pass, we will pass the head node of the rider and the rider id, then it will insert. Similarly for driver, that pointer of the driver, linked list of the driver and the driver id. When we have to match the driver with rider, if rider and driver are, if any one of it's also not null, then our answer will become -1 -1. If there is rider and driver, then we will just return the driver id and the rider's id by the value of that, and just move front the rider's id and the driver's id. For cancelling the ride with driver id, we will just traverse whole our riders list, and wherever the current value equals to riders value, we will just delete that node of the linked list. Thank you.